Okay, first of all, thank you for having me here. It's a great pleasure to be here on this conference, and I'm extremely impressed with everything here. And second of all, thank you for the last talk, Manuel. I think it was very important. And I also have one thought about it that I will share with you before I will start, that in our lives, we have two different kinds of the things. First one, which are valuable, and the second one that are hard to get. And sometimes we confuse them, and we put our energy in the wrong place. So let's go to the main topic, so how to build a medical chatbot using Microsoft Azure and OpenAI models. So this talk will not be only about the chatbots, medical chatbots, but also how to use the large language model and all this aspect of generative AI in our products. Oops, I am stepped too close to the speakers. Okay, my name is Damian Mazurek. I am Chief Innovation Officer at SoftwareMind. In the past, I founded a couple of companies, one in the AI and cloud computing area, which was acquired by SoftwareMind. Second one is the longevity company, where we used AI to help to extend human life, and not only the lifespan, but also the health span of the human, which was also bought by one of the biggest, let's call it, diagnosis laboratories in Europe. I'm also a university lecturer, speaker, and a professional biohacker. So, by the way, almost all images and content in this presentation is generated by AI, same as this picture. So this is not a real picture of me. And before we start, I need to introduce you to the SoftwareMind and give a couple words about it, because we are the global software development company that helps to create innovative products, projects, and services for many different companies from different areas. And we are located in many different continents, countries. So if you want to know more about us, we have a stand right next to the door, so please go there and ask. Okay, and that's all about the company. Let's go to our story. So here our story begins, because every product, every service, everything that you are building is a story. And the story has the beginning, the hero, the villain, and the problem that need to be solved. The same is here. So our story began in the city of Amsterdam, where there was a big problem with medical healthcare. So normally, if someone gets sick, he or she needs to wait something about 3 weeks before they will able to reach someone who's called company doctor. So this is the specific, let's call it, medical professional that is specialized in this first contact medicine and is able to give you the sick leave inside your company. But the problem was that many people are recovered in this time or get sick even more worse, because 3 weeks is a lot of the time. And another important problem there was that your employer cannot ask you why you are absent from the work. So in Amsterdam city, there is a problem that 10 to 15% of the people are missing, and nobody knows why they are not coming to the work, because they cannot ask it for the employee if they are sick or why they are absent at the work. So this was a big problem for everyone, starting from the doctors, who has very long lines of the patients, and they do not know who needs the treatment at the beginning, for the people who need to wait 3 weeks, and for the employer, because 15% of the people that are missing is quite a huge number. So, like in every story, the hero was born. And there was one person that thought, we can use AI to solve it. And as you know, almost everyone were using ChatGPT in the couple of the last year. Same was here. So this person opened the ChatGPT, tried to create some prompts, and saw that it was really efficient in this. So the idea was to add some additional layers, additional functionality, and sell it like a product. And like with every hero, needs something, one thing, that will enable them to succeed. And this is the guide who will help him to reach his full potential and build a good product. And here we came to the picture. So before we go further, I will just address what are the large language models and how they work. I know that at the first presentation, the speaker was talking about it a little bit, so I will just skip what it is. And I will concentrate on how it works. So as you remember, large language models are machine learning algorithms that mostly are based on the transformers architecture. And transformers architecture adds the specific attention layer for every large language model that allows them to add 3 additional information. So for every word, for every sentence, when it is tokenized, so represented in the uniform way, they add 3 information. They add the query, so we can understand like the question to this word, to this sentence. They put the key, so we can understand this as the, for example, key message, and the value. And the value we can interpret as the main value that this sentence, this word, brings to the meaning of this sentence, of this, let's call it, information part. Of course, they are mathematical metrics that are counted in the training process, but we can imagine them like this additional information for every word, every part of our sentence. Okay, so when we have these models that are operating on the words, how can we, well, there is some malfunction here. Now it's working. So how can we teach them the specific skill set? And there are 2 different approaches. One is through the training, and second one, we'll talk a little bit later about it. But when we are speaking about the training, we have 3 different layers of the training. First one is our basic training. Let's call it stage 0, the next token prediction. So here we need to imagine that our large language model is like a baby. We need to teach them the specific words. We need to teach it how to speak. And this basic training creates something that is called foundation models, so the models that are trained on the general knowledge that are able to generate text. And then when we have this model, which is already know how to speak, we can go to the instruction fine-tuning. So based on the words and the prediction of the next words, we can train it to do some specific stuff. Like, for example, answer the medical question. Like, for example, to create code architecture or anything else. So this is the instruction fine-tuning. We have some questions, some instructions, and we have the result, and we fine-tune it to answer the specific question and specific instruction in the specific way. And there is third, let's call it level, called reinforcement learning from human feedback, where we, as the users of such models, systems, can say if the answers, if the text, if the tasks or solution for the task generated by the model are correct or not, and how the model should correct it. And this is the phase on where, for example, OpenAI and most of these big companies are working right now. So it's the reinforcement learning from human feedback. But there are some problems here. So first of all, first problem is the high cost of training. If we want to train the model from the scratch, like GPT 3.5, then this is the enormous cost. So I spoke with my friend from the Microsoft product group that built the infrastructure for the OpenAI for training the models, and he said that they used 7,500 of Kubernetes node only for training GPT 3.5. And the training process was very long. So imagine how much it cost. 7,500 virtual machines with the GPUs and very strong GPUs that were running constantly for the months. So this is the problem. And normally, if we want to build such a system, we don't want to invest a couple millions of dollars only to prepare the model. Most of there, when we go a step further and we want to fine-tune the models, so we have already trained models, so fine-tuning is much more cheaper, then the problem is that there are the research papers that show us that the strongest models, and right now is the GPT-4, is operate much more better when we used the let's call it few-shot prompting on it, then the models, smaller models, like GPT 3.5 or even smaller, fine-tune to the specific tasks. So if the model with the general knowledge is better than the fine-tuned models, for example, open source models or another one from the competition of the OpenAI also, then why we should use fine-tuning, which is also much more expensive and consume much more time, if we can use this few-shot prompt technique. And another thing is hallucination. This is what was told on the first presentation. Large language models are working very similar to our brain. So if we remember something, sometimes we just confused and we think that we know something. We think that we remember something that really doesn't happen. And the same is with the large language model. They also hallucinate. They also sometimes create the facts that do not exist. And to address all of this, we can have many approaches to this, but I will present you two of this approach today. First one is, okay, let's go to this, role prompting. So in this technique, we want to define how our large language model will behave, what kind of the responses it can generate, what specific, let's call dialect he will use, what specific problem it could solve, what it should not do, and what are the specific flaws that this model should be aware of and should respect. And this is one of the more important techniques for creating accurate usage of a specific large language model. And here there is a simple flow. At the beginning, we specify the role. So in this case, let's say we are specifying the role that you are the medical AI assistant, that the main task is to diagnose people. You need to ask them or gather this and this and this information. You need to help them with this, and at the end of the conversation, you need to calculate the recovery time based on additional models. And I will tell you about this one a little bit later. So now when we define the role, where we describe the flow that is required for the model to do, this model will behave in this specific way. And also, when we are using the, let's call it the chat models, because there are normal text generation models and the chat models. In chat models, we are able to define something that is called system messages, the messages that has the highest priority, and define how our large language model can define. Then when we define this persona, we use this model, we check the responses, we adjust it, analyze it, and in this agile way, adjust our, let's call it role prompting. And this is the first thing. This will allow the bot to behave in the specific way. But very often, we want something more. We want this bot to be able to use the real-world data, and we need it to be able to solve the problems based, for example, on our private company data, on the data, very specialistic data, or on the, let's call it, some kind of the data sources that are defined, and the model by itself was not trained on them. And here we go to the technique that is called retrieval augmented generation. It's called RAG. When in this methodology, we use in our, let's call it system, first of all, when we submit a query from our user, we search for the relevant data. And we do this using the embedding process, and I will describe you in the next slide what it is, and retrieve the most relevant data for a specific user query. When we retrieve this data, then this data with our question or task is sent to our large language model. And we ask large language model, based on this data, answer this question, or based on this data, do this task. And then we create, this is called the prompt template, that allow the model to know that it needs to done the specific question or the specific task based on this data, and then we send it to the model. And model based on it create the response for our end user. And thanks to this, we solve many different problems like hallucination, because if we decrease the response temperature, so the creativity of the model, we can understand it like this, then it always will be based on the data that we put as our RAG data. Okay, so how it is done under the hood? There is a process called embedding, because every model is just a mathematical model which computate the numbers, and every of word or every of data, because now are they also the multimodal models, need to be represented as the numbers. So one of the most efficient technique right now is called embedding, which provides us the ability to represent any, let's call it, value, any word, any image, anything else, in the vector space of the features. So if we, for example, have a table, and we want to represent it, embedded it, then we will create the n-dimensional space with a specific feature, like, for example, height, like, for example, shape, like, for example, number of legs, etc. And then we numerically represent the position of this table in this space. And because of this, we can map every word in different language to the space of the feature. So whenever we will search something, we will search by the meaning, by the representation of the word and not by the word by itself. And thanks to this, we can get very relevant and accurate from semantic perspective data from our database and use it as the input data. And also this mechanism often calculates something that's called relevance score, which provides us information how relevant this specific information are to the specific query. And all of this is done by our data indexing when we are using our vector database and the embedding process, where we load the data to our storage, we create the service that will embed it, we split it to the smaller chunks of the data, because remember that our large language model has the limitation in the input and the output context, so they can process only limited number of the tokens. And then we search the database, we get the most relevant chunk of the data, which are stored together with the vector representation of this data, and then use it as our input query to our large language model. And okay, so as you can see, there are many different actions, and this is only a part of these actions, that we need to do to build our system based on the large language model. So here is the, let's call it, generic architecture that I created some time ago. And we built many different, let's call it, LLM-based chatbots based on it in different area. The technology implementation of the specific, let's call it, blocks is different. But this architecture is able to address all of these requirements. So at the bottom of this architecture is our large language model, and then can be more than one, because we can use many different large language models to different tasks. We can use one for the embedding, so transforming the words to the vector representation. We can use one for answering the simple questions, which could be a smaller one, and we could use the biggest one and the most powerful to answer more complex questions, to create execution plans, or many other very complicated stuff. Okay, on the right, we have, so now on my left, sorry, we have the whole services that are responsible for our RAG process. So at the bottom, we have the storage when we put our data, and this data could be in the different forms, like text data, tabular data, structured, unstructured. It could be even the images, sounds, or videos, because as I said, we have many multimodal models where embedding process could be done in every kind of the data. Then this data are indexed by our data indexing service, and this service sends the request for our embedding model, and from that it stores the vector representation of this data in our vector database. Here we can use many technologies to address it. We can use cloud solutions, like you will see in the next slide, or you can use the open source database like ChromaDB, Quadrant. You can use the additional plugins to the Postgres, MongoDB for a vector search. So here is, well, the huge possibilities. Okay, next we have our main core of the applications, our web application and the backend, which we need to develop. And this is very important because most of the models are stateless, so they do not remember anything. So we need to create the short-term memory and store it and also prepare it. Because when every request comes from our user, we need to save it. We need to save every response from the large language model. And at every request, we need to put it inside the request so the model would know what was the history and the context of our conversation. The problem and the trick is that, as I said, the input is limited in large language model. And what does mean? That sometimes we cannot put the whole, let's call it conversation, so we need to use different techniques for creating the memory, like the summaries, like the moving buffers, etc. And also there is another problem. So in the big model like GPT-4, where we have, I don't remember exactly it's something about 32,000 tokens, and we have this experimental large language model that had 100,000 tokens, LongNet from Microsoft. The problem is that, and there is some research papers on this, that large language model, and this is the limitation of the attention mechanism, the best way or the things that it remembers are that ones that are at the beginning and at the end of the text that we provide to large language model. So in this case, if the conversation is too long, if the text is too big, it will concentrate on the beginning of the text and the end. So here, we need also to prepare our system for this, to create the mechanism that will allow us to create the summary, to identify the most valuable information from our conversational text and put it in the short form and send it to our model. And the last part are the another integration like identity provider, third-party integration. So this is very fun functionality. We can put and if you are using framework like LangChain, you can address the specific APIs and tell large language model when use specific API. And it will be able to decide in which moment which API it should call. So for example, if I create the API and the method that's called check me the weather in Moldavia, then every time if user will ask, what is the weather in the Moldavia, or something very similar, the model will know that it must trigger third-party integration API and ask external system about it. And this is really cool stuff. Okay. So let's get back to our solution. In this case, we built the system based on this architecture, based on the Microsoft Azure. So we start from something that we call released channels, so how our user will communicate with our bot. The thing most popular in Amsterdam are of course, the web application, the email, and the WhatsApp communication. So we create the integration with all of these channels. And we use something that's called Azure Bot Service, which provides us seamless integration with these release channels. Then we create the backend application based on the app services. We used Azure Cosmos DB as our short and long-term memory. We used Azure OpenAI services as our backend for large language model, which is deployment of OpenAI models inside your Azure infrastructure, but still we are using this as the PaaS service, so we use it only through the APIs. And then we add additional indexing elements on the right, which provide us the ability to index the data. We use Azure Cognitive Search, which provide all of this inside one service when we can create the index, the indexer, and just show him from where the data it should took. It automatically OCR it, embedded it, and do all this stuff for us. And also we did one additional thing. So we create the functionality of the additional machine learning classification models and label them so our system would know in which case which external machine learning model it should use. Because as you remember from the first presentation, large language models are language models. They are not mathematical models, they're not the models that can do some calculation. So when we are calculating the recovery time, we need to use additional model that is specified in this. And we need to address this on the level of the, let's call it flow orchestration, in this case using the bot service. So whenever the model will go, large language model will go to this phase, it will send the custom response to our backend that will trigger the request to our external machine learning model. And this is, let's call it, the core of our system. Well, we have only 5 minutes, so I will go further, but if you have any more detailed question, then you can find me there after the presentation. Then we have additional things, so the services to manage user identity, the services that will able to manage the company profiles, the access to the users, and the medical professional and their access to the system. I will not talk about it because this is the standard, standard software, and the large language model are the main topic of today. So when you're building this kind of the system, there's always the question, how secure are your data? Because we heard about the Samsung problem that users were using the ChatGPT and they leaked the very specific data. In this kind of the system, first of all data are encrypted at transit at in rest, and they can be encrypted by the key managed by you, because you are using your own cloud infrastructure, and if you have the good cloud governance standard and good landing zone, it's all addressed. Second of all, you have full control over your data and over your model, because this model is deployed in your cloud infrastructure. Only you and everyone you give access to have access to it, so there is no problem that this data in any different way or reason will leak at this point if you did everything correct, of course. Then you can have regular audits. This mechanism is fully auditable. It gathers the logs, the monitoring, telemetric data from every single aspect, and you have full documentation of every conversation because you store it in your memory database. Data backup, of course, you can use the automatical data backups system in the cloud. Then you have this monitoring, which is continuous monitoring. You can use the live streaming of the logs and the telemetry. You can plug the CM, in this case Azure Sentinel, to it and always be aware what's happening and what the security issues potentially could be found there. And last, well, not last, next is the content moderation. You can put additional layers, additional models that are specialized in content moderation and plug it into the flow with Azure Bot framework to this. And the last one, this mechanism enables your AI assistant to improve over time, because you can gather the information from the users, medical doctors, and many others on this, how really good this mechanism is. So what is now ahead of us? There's a medical device certification process, and we started a couple months ago with the Amsterdam City, because every chatbot, every software that is used inside the medical field needs to be certified as medical device. And another one is the technology adoption, because if we have advanced solution, it works only where people are using it. And in this case of, let's call it digital transformation, 80% are the people, 20% are the technology. You can have the best software, best solution, but if people will not use it, well, it will not work. So what is the end value? Medical doctors are able to figure out which patients they need to treat first. The intellectual workload is smaller because they work with the AI. So at the beginning, they have the patient, let's call it chat, the diagnosis, the calculated recovery time. Employers are able to get to the doctor much more faster and have the information about the health status and the recovery time. About the recovery time of the patients and employees. They do not need to wait so much time for company doctors. So let's go to the questions. Oh, so many.
Okay.
First, let's clap your hands, please, guys.
Thank you.
Thanks for the great presentation. My question about, you said a bit about, we know that language models tend to imagine some facts, and when we say it about medical chatbots, it's important. Yes, we can set temperature to no and add to context, please don't imagine anything, but which additional techniques did you use for solve it?
Mm-hmm. Yeah, so when you are using the RAG, retrieval augmented generation, there is no problem there. So every time that when model do not find the information in the database, let's call it like this, so in the vector database, it will not answer the question. And it will answer that there is no data or no information in this data, so I cannot create the answer. So this is one of the most, at this moment, most efficient technique, RAG, for eliminating the hallucination. Of course, with role prompting, and it's worked very well. But still, you need to monitor it, you need to check it, and you need to have this, let's call it MLOps mechanism that will allow you to check if this is true. Because there is always some risks, and there is no system that is 100% free of the error, and you always need to have a plan how to mitigate this risk, how to check it, and what to do if something like this happens.
Okay, thank you for a great presentation. My question is actually how your bot works with an hour content type. I mean, not with text, but with images, videos, if in general it works. And if it's possible to insert a scan on my hand in WhatsApp and this data to be processed.
Mm-hmm. Yeah, so it depends what is inside the scan. If there are some, this is the medical scan with some data that are somehow written as a text, then it will just OCR it and it works good. But if they are some kind of, charts or more advanced, like, I don't know, X-ray of your lungs or something like this, so at this moment it does not provide this functionality, but it is built for it. So in the future, we want to add additional models, like for the X-ray classification, another disease classification based on the results of specific, how to call it, operation in the laboratory where you gather this data. But this is for the future. So we have, as you remember, this part with machine learning additional model. So then when you upload it and you put the context, for example, that this is my X-ray image or this is something else, it will be directly sent to these additional models.